Hi, today we're going to be talking about Chapter 9 in Dr. Vaughn's The Power of Critical Thinking, and Chapter 9 looks at inference to the best explanation. This particular idea of inference, figuring out reasoning from premises to a conclusion based on those premises to explain something that is not quite exact or perfect or absolutely fact-based. This is where we live most of the time. We have a lot of things that we look at every day that we're trying to figure out why it happened, how we can fix it, what people think about X or Y or Z, why they think that way, what happened to create this particular situation or state of affairs. And so we use this all the time. And what we're going to do today is we're going to walk through some basic kind of reminders about what we've learned so far, and we're also going to move forward into how do we use this, how do we judge theories based on what's the best explanation and what all that stuff actually means. So to get started, we're looking at basics, things that we've learned so far. Remember, in this case, Dr. Vaughn starts the last section of the book, chapters 9 through 11, with this inference to the best explanation. And he wants to make sure that we remember, here's all the stuff we've learned so far, and now we're going to apply all of this, okay? So we've got this list of basics and definitions on the little orange box at the bottom of page 320. We know that statements and premises and conclusions basically have the same definition, right? They are an explanation or an assertion that something is or is not the case, okay? And if we have a premise, it's just a statement that we use to back up our conclusion, okay? Most of the time, we have 2 or 3, 4, 5, 10 reasons that our particular claim or conclusion is true. And in the case of inductive argument, those premises are still required to be true in and of themselves. What we base them on then, what we base our conclusion on then, is that level of truth, but we're kind of taking it another step forward, okay? When we're looking at an argument is just a group of statements where some of them, the premises, are meant to support another of them, the conclusion, okay? The indicator words are nice to have, things like because and since and for and therefore. We love to have them because that really points out the structure of the argument to us, but they're not absolutely necessary. And you'll see them less and less in inductive arguments, okay? Because we're not working with conclusive evidence. We're working with probable evidence, okay? So remember, we have those definitions as well. Deductive argument, conclusive evidence. Valid or invalid structure. We're talking about sound truth, okay? Sound content. With inductive arguments, and that's where we live most of our lives, right? Kind of that partial credit area. We live our lives in inductive. We're looking at things that are probably true. And this is not some less than or failed kind of deductive argument. It's a whole different animal in and of itself. And so inductive argument, we're looking at probable evidence, strong or weak structure, okay? And then we're looking at cogent, which remember just means thoughtful, truth or content, and or failed content, just like with deductive arguments. So our inductive arguments, we're looking at inference, okay? Inference, that reasoning from a premise or premises to a conclusion based on those premises. Now, that sounds pretty straightforward, almost a no-brainer, but if we just look at a few of the arguments we see on social media or even in some of our news sources, that's not always the case, okay? They're asked a question, we're trying to figure out an answer, and there's this other thing that they talk about. We're looking to stay on task. We're looking to stay focused on a particular idea here. So inference, and that's our first new thing. We actually had this as a big word back in Chapter 6, but we're going to expand on that in Chapter 9. And we're going to do that by talking about inference to the best explanation. And if you're in the book, you need to be looking at page 320 or so. We're just going to kind of walk through things, make sure we're on the same page, okay? Now, we know that an explanation, okay, explains something. Well, that's not a very useful definition, right? But it tells us why or how something is the case. So an explanation is a little bit different from a statement because a statement can be evaluated as true or false, okay? An explanation is kind of an expansion of that. we're looking at why something could happen, what happened, how it happened, the process by which it happened, okay? Excuse me. We're having a lot of inference here because we're looking at kind of reasoning from one point to another, and we're trying to explain how that happened, okay? How did we get where we are? And part of that helps us because it looks at what the motives behind things can be, the process, the procedure, the steps we take, all of those things can get incorporated into an explanation, and it's not necessarily a straight statement, okay? So they differ in important ways. When we're looking at inference to the best explanation, and this is on page 322, inference to the best explanation is we're going to reason from premises about a state of affairs, and don't let that terminology mess you up. A state of affairs is the same thing as a phenomenon or a situation or an event even. We're looking at this particular thing, and we're trying to figure out how it got there or why it works, or more often than not, why it doesn't work, right? Something's broken and we need to fix it. First, we have to figure out what got broken, okay? Why won't my computer connect to the internet, for instance? There are lots of reasons for that. Which one is most likely true today, okay? So when we look at explanations, we have two different kinds, right? We have theoretical explanations, which is where we're going to live most of the time in this. And theoretical explanations just mean we don't have the capability or the observational skills or whatever it is to know this particular thing absolutely. And so we're explaining how this could have happened. It's a theoretical explanation. And some of our theories make it into the realm of fact, okay? Gravity was once a theory. We know gravity is an absolute truth, right? Everything pulls in towards the Earth's surface, actually toward the Earth's core. But that was a theory. We had to prove that. And again, even some things that seem very obvious to us now were not always the case, okay? And so some things that aren't very obvious to us now may in the future be obvious and become not theoretical, but definitional. And that's the other piece. We have theoretical explanations and we have non-theoretical explanations. And Dr. Vaughn goes through a little bit of that. If you look at the book, there's a little, the lore of explanations on page 324. Things like teleological explanations. These are explanations about the purpose of something, the why, okay? And he goes into and gives us some examples, okay? The wall switch is there so you can turn off the lamp from across the room, okay? What's the purpose of a light switch? Okay, so you don't have to climb up in the ceiling or pull a chain or whatever used to be the case. Interpretive explanations, it's meaning, okay? This is our dictionary definition, right? Our denotation kind of stuff. And then there's procedural explanations. These are the steps, right? How do we do something? What do we have to do in order for that particular end product to be created? Whether it's a manufacturing process or a baking process or a paper process. I mean, any of those things go under procedural knowledge. And so we have, different kinds of explanations. Theoretical explanations, things that we're pretty sure are true, but we can't actually set them down in stone. Non-theoretical explanations, things that are explained in ways that we know work, okay? They have their basis in fact. And those things are on page 324, and we're going to use those in the exercises for homework too, so it's a nice little thing to note. When we look at inference to the best explanation, some of the most prominent ideas, some of the most prominent examples of that idea show up in science, in medicine, okay? How does this work? Why do people get diabetes? How do we fix that? What can we do to alleviate the symptoms and keep them alive longer and all those kinds of things? But we also have two very prominent ideas that really showcase this inference to the best explanation. One is Darwin's theory of evolution, okay? Now, wherever you are on that, We know that microevolution is absolutely true. Okay, certain species of animals, people even, we adapt from one generation to the next to fit better with our environment. Okay, birds and their beaks and moths and their coloring and all kinds of things have shown up inside one particular species, how it changes to fit its environment. That's microevolution. That is a scientific fact for the most part. For the other one, macroevolution, can we trace from a single-celled organism to complex organisms like human beings and whales and that kind of stuff? Most of science would say yes, and here's the proof. Okay, but it's still in the realm of theory because there could be other explanations. And so that's one of the big ones for inference to the best explanation. The other one, and this is a little less controversial, is Sherlock Holmes. His method of induction reasons from specific pieces to a general conclusion, okay, inference, and he does so very, very well, very, very methodically, and it always works out that he's right. Okay, it helps that he's a literary character and not, your local police officer. But part of this is looking at ways to see the bigger picture as far as inference goes. So if you're really in the mood for a good read, go look at Sherlock Holmes. Now, there are lots of theories we have to explain certain things, and we take these theories as basic fact. Why, if somebody comes to school with the flu, why then do half the class come down with the flu? Well, we have this germ theory. There are viruses that run around and infect other people. And if you are in proximity to somebody who is ill, you are more likely to get ill. Those kinds of things come up very often as far as theories and things go. Now, there is a pattern for inference to the best explanation, okay? And I have it over here as ITTBE, okay? Inference to the best explanation. You have this. You have this phenomenon, and we're going to call it Q. Okay, everybody calls it Q. It's one of those weird things. Logicians like P's and Q's and R's for some reason. Okay, so the phenomenon Q exists. That's my first premise. My second premise is this capital E explanation is the best explanation for Q. So E is probably true. And that's it. Okay? This is very deceptively simple. There are lots of things that go into deciding that phenomenon Q needs an explanation, has an explanation, should be explained. Okay? This explanation here, E, capital E, is the best explanation. When we use this term, this descriptor, this adjective, to say it's the best explanation, that means there are others. Okay? If there were no others, we would just say E is the explanation. Okay? E is the best explanation. Okay, well that means we've gone through some steps and we know this is the best, most probable explanation for our phenomenon, our state of affairs, our situation. So E is probably true. Again, we're living in the middle of inductive reasoning here. So if I have this set up, and this is my formula, this is my format, my structure for that particular argument, I have to figure out a way to get to this. How do I know which one is the best explanation? Well, there are ways to do this. There are a couple of things that are very, very important. One is consistency, and one is adequacy. And we have a couple different things we have to do with those, okay? So I know I'm going back to doing my backwards thing, but when I'm looking for, and I don't want to do criteria first. I want to do consistency first, because that is first. If I'm looking at consistency, okay? Now, we know consistency as kind of texture and that kind of thing, especially when you're baking or whatever. But consistency here means it holds up to scrutiny by outside observers, right? And so we have two different kinds of consistency that we have to consider here. We have internal, which just means it's not contradicting itself. Okay, if my theory is internally consistent, that means it doesn't contradict itself. It doesn't say on Monday that X is true, but on Tuesday X is false. Okay, X is true all the time. The other way, easy enough, is external. Okay, this means it actually explains the data it's supposed to explain. Now, this sounds pretty easy, pretty no-brainer, but imagine, okay, a lot of the arguments and things we see on social media, you're asked a question, okay, how does this work? How does this particular thing work? Well, let's see, we have to go back to, 20 years ago, when, and there's no real explanation there. If we have a theory that contradicts itself, but it actually explains the data it's supposed to, we still have to discard it. It has to be true for both of these before we can even put it in the running to be the best example, the best explanation, okay? So once it's been shown to be internally and externally consistent, then it's eligible. Dr. Vaughn gives us, this is a huge deal, okay? The best explanation, okay, the best theory is the eligible theory that meets the criteria of adequacy better than all of its competitors, okay? In order to be eligible, it has to be consistent in both ways, internally and externally, okay? Then we get the criteria of adequacy. Okay. Now we don't think adequate is enough, right? If something's just adequate for the job, we'd like to have something that's better. But in this case, we're talking about a theory that is worth our acceptance, okay? And it's how we determine which one of those that are eligible are really the best one, okay? So you need to look at internal and external consistencies on page 332. The criteria of adequacy notes, the review notes, are on page 335. Okay? And we have 5 criteria. Okay? The first one is testability. And really, the definition is in the word itself. We are able to test this particular theory, whether it's in a lab or by observation or whatever. We're able to test and see if it's true or false, okay? And we can move it under different environments, different ideas, and see if it's still consistent, okay? So testability is first, okay? Then we have fruitful. Okay, testability. I'm going to do this. Able to be tested. Fruitful makes new predictions. Now, here's the fun part. Something that's fruitful makes novel or new predictions, okay? And this means it makes predictions outside the data it's supposed to explain. Because if it doesn't explain the data it's supposed to explain, we don't even have it on the list, right? So when fruitful is defined as making novel predictions, it has to go beyond what we're actually looking for. Now, sometimes this is very important, and other times not so much. We're going to get to that in a little bit too. Then we have the scope of the particular theory. This makes different, okay, diverse predictions. And our diverse means different, right? So under different situations, in different environments, different modes, we're going to look at this thing's scope. And the more diverse predictions it can make, the better the theory is, the more likely it is to be true. the more new prediction it makes, okay, the more likely it is to be true, or the best one. If it's able to be tested, okay, it depends on the theory, right? We can't test the Big Bang Theory. There are lots of things that we hold as fairly obviously true that we can't test. But if we can test it, but we can't test the rest of the theories, then, okay, somebody wins there. So these three, we're looking at how much, and the more the better. The last two, simplicity and conservatism, we're looking at keeping these numbers low. Okay, I'm going to get to that in just a second. These, more is better. These, less is better. Okay, so keep that in mind. Simplicity refers to the number of assumptions we have to hold in our heads for this to be true. Okay? Okay? The number of assumptions. And most of the time, these assumptions are things we have to make that are outside our background knowledge, outside our normal understanding. A lot of things that fall into this not so simple category are things that are spiritually based, supernatural, those kinds of things. Because we're talking about logic and science here, anything that falls outside of things we can see, smell, touch, hear, that kind of stuff, we have to hold too many things in our head. Doesn't mean they're not true, just means we can't prove them scientifically. And this last one, conservatism has nothing to do with politics, okay? In this case, this is how well does it fit? How well does it fit specifically our background knowledge? Anything that asks us to go against our well-supported beliefs, our background information, is less conservative than the next piece, okay? And so we want things to have as few assumptions as possible, and we want it to fit in with most of our background knowledge. We don't want to have to go outside of that or contradict that for it to be conservative. So less is good here, more is good here. And anytime we're walking through these theories and we need to figure out which one is best, we can just use a little chart, okay? My little COA chart, and I just run test, fruit, scope, simple, conservative, okay? And then I have theory 1, or I'll give it a name, okay? Theory 2, theory 3, and then it's just yes and no. Can I test these theories? Sure. Is each one fruitful? Okay, this one makes some new predictions, this one not so much, and this one does. Am I able to make diverse predictions? Can I use this in a variety of situations? Well, no. None of them get a yes on that. Theory 1 is simple, but it's not conservative. Theory 2 is neither. Theory 3 is not simple, but it is conservative, okay? So I have theory 2, I don't have to worry about, okay? It only got one yes, we can test it. Other than that, it's not good for anything else. Theory 1 and theory 3 both have 3 yeses and 2 nos. So I have to determine, in this particular case, is it better to be simple or better to be conservative? And it depends upon the theory itself, okay? It depends upon the situation itself, not the theory itself. And so I decide that I need it to be conservative more so than I need it to be simple. And so then theory 3 is my winner, okay? And when you're asked in the exercises to explain your answer, when it comes out this way, you need to explain why conservative is more important an attribute than simple, okay? And that's really all that is. But anytime you're asked in the exercises to talk about the criteria of adequacy, you can use the chart. You don't have to write it out in paragraph form, okay? Paragraphs sometimes take a long time, but that's the pieces on that one. There's one more piece, and before I get to that, Dr. Vaughn does walk through each one of these definitions, each one of these criteria in some depth. And so go in the book, read your stuff. And we have some interesting pieces here. Best explanations for things. He walks through quite a few. He even talks about some conspiracy theories that you might find interesting. And then we have, at the bottom of 347, we have a couple of things about explanations about this criteria of adequacy, okay? There is no strict formula for determining how we go about doing this, okay? Sometimes fruitfulness is going to be the top criteria we need to consider. Sometimes testability, sometimes scope. You get the idea. It doesn't mean that what we're doing is subjective or arbitrary. What it means is we have to be flexible in how we're putting these particular criteria to bear on our theories based on what's at stake. Okay? If we're looking at a medical breakthrough, we want to know it's testable. Okay? We want to know it fits in our conservatism and our simplicity. We are not as worried about the fruitfulness or the scope of it. We're wanting to make sure that it's really a breakthrough, that it's really going to help people. And so we have to be able to test it and retest it and replicate what we're doing. We're going to talk a lot about replication in chapter 10. Okay. Now the last piece here, the test formula, my last thing on my agenda here. The test formula really is kind of a funny thing in my mind. Telling good theories from bad. You have the list at the bottom of page 349. And really, it's not an acronym as much as it is a procedure, okay? So my test theory, hoping you guys can see this. My test theory has 4 steps. Step 1 is to state the theory. And there's your T. Oops, I have to be able to spell. Test the theory, state the theory, okay? And check for consistency, okay? Run it through this internal and external. Step 2, okay, is, assess the evidence, okay? My second letter is E, evidence that the theory is based on, okay? Make sure that the evidence is true, comes from reliable sources, makes sense for what we're looking at, actually answers the question, all those fun things, okay? So assess the evidence. Step 3, scrutinize, basically look at carefully, alternative theories. Remember, we're trying to get the best theory, so we have to make sure the others that are out there aren't better than ours. And step 4, test the argument, test the theories with the criteria of adequacy. There's my T. With COA, okay? So really, this is, 8 steps, right? So we're going to state the theory, here's my T. We're going to assess the evidence, we're going to scrutinize the alternative theories, and then we're going to test the theories with the criteria of adequacy. We're going to run it through our little chart. Once we've done that, we can then say, okay, theory 3 is the best theory, so it's probably true. Okay, all of that work just to get back over here and get from step 2 to the conclusion. But we're used to a lot of work. Remember those lovely, lovely truth tables, okay? Dr. Vaughn then walks us through 2 very good examples of using this particular criteria of adequacy and the test formula to walk through some theories. One on TWA Flight 800, the other on homeopathy, whether it works or not. And he gives us an example of a little chart on page 356. Okay, so when you get to the end of chapter 9 and you're working on the homework, make sure that you're following the directions. Okay, he leads us through things kind of step by step. He's going to do the same thing in the homework. Make sure you're following direction and answering all the questions. Some of them have 5 or 6 questions for each problem. That's why you've only got a couple to do in each section. But make sure that you're actually following the directions. When it asks for a paragraph that explains your choice, 2 or 3 sentences will be great. Okay, I'm not expecting a half page. 2 or 3 sentences are fine. Okay, so this is all for chapter 9. I'll be back in a little bit with chapter 10. Happy day.